I want to start today with a warning discussion. So we're entering the phase now in the class where I'm going to start introducing data, and I'm going to start introducing conceptually good approaches for presenting that data and good ethical approaches for constructing figures. So I just want to be clear that we're segueing now for a couple discussions. Any discussions on data are separate discussions away from the art field. Okay, we're no longer in the art field, we're talking about the scientific field. Remember, in the first lecture, I talked about how the rules are different. So we're entering now a realm in which the rules are different. The rules of art don't apply here, the rules of science apply. And I want you guys, I don't want you guys to be naive. I want you guys to know that there is a dark side and a light side to Photoshop. And in many ways, Photoshop has both a good and a bad reputation among scientists because scientists in the past have used it unethically to present arguments that were flawed through manipulated data. So I feel compelled to tell you specifically, do not manipulate data. Do not manipulate data. Do not ever manipulate data. Now, when I say this, there's different kinds of data manipulation and there's different kinds of plagiarism. So we might as well just enumerate them and discuss them. So I'm going to share this article with y'all, and I hope that you guys look through it and take it very seriously and consider all the points within. Now, essentially, data manipulation is the process in which scientific data is forged, presented in an unprofessional way, changed. You cannot do that. And there's lots of motivations for this, especially when academia, when you start rising up. There's lots of pressure, there's lots of competition, there's lots of people trying to get an edge, and there's a lot of the conditions that sort of foment people thinking that this might be a good idea. But let me just be clear, this is never a good idea, and it will always hurt you much more in the long run, and it will have the potential to essentially destroy your career. So one form of data manipulation is omitting important facts. And with respect to what we're going to be discussing, this could be potentially a cropping issue where you're cropping out relevant bands that might change the interpretation of a figure. That could be an error of omission. So always err on the side of caution. Let me write that down. Always err on the side of caution. That means that if you ever have a decision to make and the question is, should I show this or should I crop this or omit this? If you're not sure, you always err, you always choose I should show this. I should show this. Okay. You always err on that side. This is the safe side. You can never get in trouble for showing everything that the data shows. You can never get in trouble for that. Okay. That's the best way. That's the best strategy. So always err on the side of caution with respect to omissions. And there's always, there's reasonable, respectable ways you can do this. If you feel like there's something that isn't necessarily pertinent, you can omit that, but perhaps show that in a supplementary figure. So you might omit that from your main figure, but you're not leaving out that possibly important data because you're showing it in a supplemental figure. And then reviewers can sort of have access to that information and they can go to that if they feel that that's important. So always err on the side of caution, and there's creative ways in which you can do this effectively and still communicate data effectively. So show everything that needs to be shown. Let's talk about this one, data dredging and fact fitting. So this is the idea that if you have a large enough data set and you have sort of like a hypothesis, you can always dredge through gigantic data sets looking for, and what this is called cherry picking, looking for cherry picked facts that, when strung together, can support your argument. But usually, what this is a result of is, so usually what's happening here is there's a gigantic data set with many, 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 many elements, enumerative, maybe thousands, maybe hundreds of thousands. Okay. And what people are doing is they have a hypothesis, which is, say, X, and the problem starts because they've already made their conclusion. They've already decided that hypothesis X is true. And then the mistake they make is, because they've already decided this, they biased themselves. They're biased. And now they're looking through this gigantic data set to pick out, to cherry pick the little nuggets that support this without showing, so this is another error of omission, without showing, say, these pieces, which might completely rule out hypothesis X. Okay? So this is called data dredging. Don't do that. And I would elaborate on this further. This is one of the reasons why our society today is in such turmoil, is that many, many journalists and many people who are trying to report on something that might be something that would in theory be scientific, they approach it with a pseudoscientific aspect by data dredging to support the conclusion that they want to make. And then they write an article justifying that hypothesis. Don't do that. One of the easy ways you can kind of prevent yourself from doing this is to think beforehand. Think beforehand how you're going to analyze the data. Think beforehand how to analyze the data. And a crucial point of this is always have a positive control and a negative control. These are parts of the experiments that tell you, that point to how correct your experiment actually is. So a positive control would be, if my experiment is working, I will for sure see X. And a negative control would be, if the experiment is working, I will for sure not see Y. These are negative and positive controls. Always set yourself up beforehand with a robust positive and negative control. So far on the list of manipulations, we have errors of omission. Nope, spell that right. We have cherry picking. And then we have the actual, actually manipulating images. Don't ever do this. Let me show you an example of this. So here's an example of this. And now that you're starting to understand the mechanics of Photoshop, you can see how easy this would be to do, how tempting this might be. I just want to say again and again and again, don't ever do this. This is never worth it. So what this person has done here is they have some conclusion that they have decided that they want to make, but their data is not showing that conclusion. Perhaps they want a band right here. This is a DNA gel. And so what they did is they take a picture and they literally just copied this band right here. They probably just used a selection tool, copied it, and pasted it right here so that they could make the conclusion that they wanted. So they're actually positively manipulating the data, making changes in the Photoshop program to produce data that's not real. So this is a real issue that we need to discuss in this class because we're using Photoshop and because I'm teaching Photoshop to scientists. And I agree with this paper that one of the ways in which you can prevent this is to talk about this and to educate people about this, to educate people that this is wrong. So that's why I feel compelled that I must have a lecture like this. Now let me go further and let me clarify and say why this would never be to your benefit. to do these things? Why is this never in your interest to do these things? One, it's extremely easy to detect. Okay? We know, let me get that image. Photoshop is entirely pixels, okay? There are computer programs which will just compare these pixels to these pixels, and they can tell it's the same. Look at this. Here's a good example of this idiot, okay? Look at how easy. This is an easy pattern that even your eye just detects. And I mean, this image itself is horrible because they're cropping and they're putting separate gels together, okay? So don't do this. You're going to get immediately caught. So you will get caught. Now, the second thing, if you ever work on anything that even is remotely important, science is about reproducibility, and people will try to reproduce your experiments. There are other labs. If you ever work on anything that's important, another lab is going to try to repeat your experiment. That is a fundamental aspect of science, is reproducibility. So don't ever set yourself up. Don't ever think you can fool people by producing a fake result, because down the line, maybe not this year, maybe not next year, maybe 5 years from now, maybe 10 years from now, maybe 20 years from now, somebody's going to reproduce that data. And if it's not reproducible, if they can't produce the experimental result that you have synthesized, you're going to be in deep shit. So don't do that. Now, let me just say a final point, which I think is, I mean, to be honest, the most convincing. If you're in science, your goal is to discover truth. Your goal, that's the whole reason to do it. If you're not interested in this goal of discovering like what's true, then don't get in science. Don't be involved in it, because that's the whole purpose. So your goal is to discover truth. So synthesizing data just fundamentally defeats the whole purpose of science. It doesn't make any sense to do that. Don't waste your time. Your goal is to discover truth, so do that. Now, I'm not going to Google cautionary tales, okay? Because there are all kinds of cautionary tales, examples of people who falsified entire papers and published them, tried to publish them in high impact journals, and then were completely found out and destroyed their careers, okay? So there are enough examples of this where, like, you don't want to do this. You don't want to repeat and follow in their path. This is the specific example that the article I sent out is discussing. Now, in science, we have a saying, the data is the data. Now, what this means is, it is what it is. The facts are what they are, whether they agree with your hypothesis or not. Either scenario is a good scenario where you learn a little bit. You learn a little bit about why an experiment failed. You learn a little bit about truth. The data is the data. You shouldn't be biased. You shouldn't be approaching it with sort of a biased philosophical attitude. You just want to discover what the actual pattern is, what the data is. The data is the data. So just do yourself a favor and report the data.